Moving on with the solutions to the logical reasoning section of the free law prep, in today's video we will have a look at part 2 of assumption-based questions. I'd recommend for you to first watch part 1 of the assumption-based questions and then watch this video. What we'd learned essentially about assumption-based problems is that you'd find that an assumption is basically a step that has been skipped. You can see that there's been a jump, and identifying that jump is the key to being able to identify the assumptions. Let us clarify this concept a little more by looking at a few more problems.
Interesting question. In fact, you will find that solving this problem will even help you sometimes in your daily life. Okay, pause the video, try solving it yourself, and then we'll go for it together. So I told you a little while back that being able to spot the conclusion is a very helpful way of identifying the structure of the argument. In this particular argument, there's a very clear indicator of what the conclusion is. Can you spot it? When you see that it says we can be certain, okay, we can be certain that, this is a conclusion. So what is the conclusion? The conclusion here is that the potato salad caused the sickness. So it says we can be certain that it was the potato salad that caused the food poisoning of those who had dinner at the cafeteria last Thursday. And then goes on to explain why. It says everyone who ate the potato salad got sick, but no one else got sick. What is the assumption in here? So here you have a premise, okay, and then you have this conclusion here. The conclusion being that the potato salad caused the sickness. Everyone who ate the potato got sick. This caused the sickness. What is the assumption? Okay, let's go for this together. Let us say this is the cafeteria, okay, and you have a couple of people who have now decided to either eat or maybe watch their phones in the cafeteria, okay. So now let us say that these people are A, B, C, D, E, and F. Let us start with potato salad. Let's say this is what the potato salad looks like, and I put potato salad into the plates of A, C, and D, okay. And then we say that A, C, and D got sick, okay. So you can say that, hey, everyone who ate the potato salad got sick, but no one else got sick, which means that the potato salad has caused the poisoning. Clear? Okay. So maybe let's say maybe there was let's say all of them had maybe they had a chapati. Okay, everyone had a chapati, everyone had this. Okay, so let's say if everyone had the chapati and only A, D, and E had the potato salad, then definitely the potato salad was responsible, right? But you're looking for the assumption in here. Let me show you how you can identify that. Okay, so the green dot is cucumber salad, and let us say again only A, C, and D had cucumber salad. Maybe everyone gave themselves some amount of rice. Maybe everyone had rice. Okay, this is rice. Everyone had rice. Okay, and maybe everyone also had maybe a glass of lassi alongside. So everybody had lassi alongside. Okay, so now when you look at this dinner table, and I look at the logic here, only A, C, and D, only A, C, and D had cucumber salad, okay, and they got sick. So now by that logic here, I can say everyone who ate the cucumber salad got sick, and we can be certain that it was the cucumber salad that caused the food poisoning. Fair? If you see, you cannot know whether in this arrangement, whether it was the potato salad or the cucumber salad. Definitely you know it was not the lassi, because everyone had lassi and only 3 people fell sick. Okay, definitely it's not the roti or the rice, because everybody ate rice and nobody fell sick. But in deciding whether it was potato or cucumber, you have really nothing to choose. So what is the assumption in here? I could have drawn a diagram and shown you, but I decided to use a different method to illustrate this to you. If you think about it, you can see that to be sure that the potato salad was responsible, you have to ensure that there was no other common dish, which means that if there was something like a cucumber salad which only these people had, okay, then you cannot say that potato salad was the one. It could be either potato or cucumber. right? So this is the assumption. Let's go ahead and see if we find this in the option. There you go. When you look at the options, you can find that option A tells you that nothing other than the potato salad was eaten by everyone who got sick but was not eaten by anyone who did not get sick, which means that the only common dish between those who fell sick was the potato salad. Okay, this is your answer. Pause the video, try solving it yourself, and then we'll go for it together. Right, so it says, although astronomers in Asia recorded the supernova of 1054, astronomers in Europe did not. Now, if you're like me, then you don't know what a supernova is, so let's just kind of draw some sparkles because it kind of sounds like that, okay? And it says that astronomers in Asia recorded it, whereas astronomers in Europe did not, okay? Goes on to say that some historians have argued, I like the word argue, okay? Doesn't necessarily point to an argument, but I don't know, you can kind of pay attention to that. That this is because a volcanic eruption in Iceland, okay, so there was a volcanic eruption in Iceland, okay, so this happened in Iceland, and it created so much dust, okay, and smoke that the supernova was not visible in Europe. So there was a volcanic eruption here, it created a lot of dust, and so people in Europe could not see it, okay. Then it says, as evidence. What is evidence? Evidence is basically giving you something to substantiate a claim that has been made. So for example, I say that I traveled by train, okay, and then I say, to as evidence I'm showing you the ticket. You must understand that in an argument the evidence does not really play a very major role, okay. It does not really form a part of the argument as much as the premise, the assumption, and the conclusion do, okay. But still, it says that as evidence, they point out that there was a massive famine in Europe that year. There was a famine in Europe. Widespread famines could be triggered by volcanic explosions due to the loss of sunlight the ash causes. So what it says is that, you know what, there was a famine in Europe that year. And let us say if this is the sun, okay, let me just draw the sun now. Okay, this is the sun. This is not the supernova, this is the sun, okay. And now there was a dust, there's so much dust here, so sunlight could not reach Europe. Because there was no sunlight, the crops that could have grown otherwise did not grow. Because there were no crops, there was a famine. So this last line suggests that this famine is evidence that this was the reason. So now when we look at the argument without, in some more clarity, what we see is that there was a volcanic eruption. Okay, the volcanic eruption resulted in dust and lack of visibility. And because of this lack of visibility, it was not recorded. Okay, so this is the conclusion, that it was not recorded because it was not visible. Okay, like I said, the evidence here is just a line that gives you evidence for the fact that the volcanic eruption resulted in this. As far as the argument is concerned, the thing that is material is that it was not recorded because it was not visible, which means that not visible, therefore not recorded. Okay, this is what the argument is. Now, this kind of ignores something, and this is where we'll find our assumption. It ignores the fact that they may not have recorded even if it had been visible. Maybe they were very busy doing something else. The astronomers in Europe maybe were looking at something else, or maybe even without the smoke, they didn't have telescopes that were good enough. You never know. So you cannot say that the lack of visibility because of the smoke or whatever was the reason for not recording. Okay, he has assumed this in here. Now we know what our assumption is. Our assumption in this argument is that they could not see it, and therefore they did not record. If they had seen it, they would have recorded it. Let's see if we find something on those lines in the options. When you know what you're looking for, these options will not make you go astray. Let me show you. Look at option A. Does it tell us anything that we need? There was no volcanic activity in Asia. Hey, that's not what we're looking for. We're looking to see the connection between visibility or lack of visibility and recording. Doesn't help. Astronomers in Europe were sophisticated, not required. No, doesn't help. Most famines are known to have been caused by volcanic explosions. Well, doesn't help. Iceland is one of the few places in the world with volcanoes massive enough to obscure the sun. Again, it is not the assumption. E. Astronomers in Europe would have recorded the supernova if it had been visible there. There you go, you have the answer. Okay? In case you don't get this, spend some time on it. Like I always emphasize, the questions that you get wrong contain the material, contain the learning that you need to improve yourself. Okay? Let us move ahead. So let us solve this question. It says, outside the bright nucleus of a typical spiral galaxy, the luminosity of the galaxy diminishes rapidly as the distance from the center increases. If luminosity were a true indicator of mass, rotational velocity, you know, if I really wanted to study science, I I thought that I'll study law to avoid all of this, and the LSAT is also testing me on science. I don't like science, I don't know science. Now how do I solve this question? Like I've always told you, these questions don't test you on science. One of the keys to solving questions in the LSAT India is to remember that anything that looks like the science in it is not really going to help you solve the question to get the answer right. Okay, let's see this. Let's do it together. Let's do it as non-science students. Okay, let's go ahead. Here's the argument. Okay, you're looking for the assumption in here. For the sake of comfort, clarity, ease, let me mark them as 1, 2, 3, and 4. Let us begin by looking at the first statement. It says, outside the bright nucleus of a typical spiral galaxy, the luminosity of the galaxy diminishes rapidly as the distance from the center increases. You can see that it is giving you a premise, right? You know it's not a conclusion. It's kind of giving you a certain rule or some principle or some law of science. Okay, so you accept it as a premise. For now, let's keep only that much because, like I said, we are not science students. We don't understand that. Let's go ahead. It says, if luminosity were a true indicator of mass, most of the mass would be concentrated towards the center. It kind of says that if something, 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 then something, something, something. Okay? It kind of says something about what would happen if something. Let's go ahead. Let's look at the third line. It says, however, the rotational velocity of a typical spiral galaxy remains constant with increasing distance or even rises slightly. It kind of says, however. Now, when you're saying however, perhaps it's going something contrary to what we've seen here, right? We understand that. And it's maybe a rule. Okay, whatever. Let's look at the fourth sentence. It says, this unexpected result indicates that the fall off in luminous mass with distance from the center is balanced by an increase in non-luminous mass. So what you see in 4 is something like a conclusion about something reducing being balanced by something increasing. Let us look at it once again. The first line says, outside the bright nucleus of a typical spiral galaxy, the luminosity decreases as the distance from the center increases. So it's more at the center and less outside. Then you see that it says that the rotational velocity of a typical spiral galaxy, so you have a typical spiral galaxy here, typical spiral, either remains constant or even rises slightly. So you saw that luminosity, right? The luminosity decreases as you go away from the center, whereas rotational velocity kind of remains constant or increases. This kind of calls for an unexpected result. You don't need to think so much, you can see that something unexpected has happened here, right? Let us move ahead. So let us put this understanding of ours into the structure that we understand of an argument, okay? The premise leading to the conclusion, and in between there's the assumption that we need to find. You know that you've been given this principle that luminosity decreases away from the center, right? The first line. The next line, rotational velocity remains constant or increases, which means it does not decrease, okay? And the conclusion, you don't need to think about words like unexpected and so on. The conclusion is that a decrease in luminous mass, I'll just call that L mass, is balanced by an increase in non-luminous mass, which I call NL mass. Now, when you see these, when you see that the premises are talking about something and the conclusion is talking about something else, the assumption needs to link these, right? So you can see that you need to somehow link this rotational velocity to this mass, because the premises do not talk about mass anywhere here. You do not see mass. So the only way you can arrive at this is if somewhere here there's a connection that is drawn between velocity and mass, rotational velocity and mass. So you can say that rotational velocity does not decrease because it is balanced by an increase in non-luminous mass. Okay? Or in other words, you can say that in some way rotational velocity is related to mass, even if you cannot think of it to this extent, right? Let's say, maybe since you've not studied science, you can at least see that in some way you've got to connect this to mass. Once you have this much of an understanding, let us go and look at the options. Now, without really feeling like this person who understands the science, just look at these options, looking for what we just saw. How do we somehow connect mass to rotational velocity? Right? That is what it is. When you look at the options, you'll see that there's only one option. It's not even confusing. You don't need to know the science. You just need to be able to identify structure. Okay? I'd like you to pause the video, be very confident of yourself, and try to identify the answer, and then I'll give you the answer in a couple of seconds. Okay, when you look at option B, it says the amount of mass in a typical spiral galaxy is related to that path's rotational velocity. It doesn't even ask you what kind of a relation. Do you see? This question does not want to test how much of a science geek you are. After all, we are preparing for the LSAT India. It does not test you on your factual knowledge of disciplines. What it tests you on is your ability to understand structure, which in itself is a very vital skill, not just for a lawyer, but for anyone who wishes to engage in logical and coherent argumentation. Let us go ahead. So again, in this question, we have an argument given in here that has a conclusion, because it says the conclusion follows logically if which one of the following is assumed. So which amongst these is the correct assumption? Pause the video and try solving the question yourself, and then we'll go for it together. Okay, sentence by sentence. It says Chanda University requires its undergraduates to take some general education courses, GEC, some elective courses, EC, and a set of courses constituting a major, which I can abbreviate as CCM. So Chanda University requires students to take these. Okay. To encourage students to take a wide variety of courses, none of the GEC or the EC is credited towards any student's major, which means that these two are not credited towards major. Okay. Because of the large number of major programs offered, none of the courses that count toward any major is over-enrolled, which means that these courses which count towards the major are not over-enrolled. Then you can see the final sentence, which looks very clearly like the conclusion because it begins with so. It says so. Some of the over-enrolled courses are counted neither toward the student major nor toward the general education course requirements. Now, as you can see, what you're looking for is that if this is the conclusion, okay, and there are some premises here, if you arrive at the conclusion here, then what is a missing premise? What is the assumption in here? This is what your target is. You can pause the video and think about it before we go ahead any further. Okay, so you know that you have here something that says that some of the over-enrolled courses are counted neither towards the student major, which means they're not counted here, nor towards the general education course requirement. Okay, which means that, you know, these could be counted maybe here towards the elective courses, or maybe there are some other courses. You see, there are some courses that are required to be taken by undergraduates, these three. Apart from that, there could be some other course for the students who are not undergraduates. There could be some courses that are not required, So you might have some other courses. So what I'm trying to say here is that it says that there are some over-enrolled courses that are counted neither towards these nor these. Okay, which means it has to be either for the elective course or for some other course. Now that we've given it this thought, let's look at the options. Now, so we know on the basis of what we thought that some over-enrolled courses are either EC or maybe something else. Now what you'd find in the options is something that gives you the same thought, but maybe not in the same words. Look at the options and see which one you can pick. If you look at option A, which is the answer, it says some of the over-enrolled courses are not GEC. So some of the over-enrolled courses are not GEC, which is kind of right because some of the over-enrolled courses are EC or they are something else, right? So you find that you've gotten your answer here. If you found this question difficult, not a problem. Think about it and see as to where you went wrong. When you get a question wrong, it gives you an opportunity to identify your own flaws and correct them.